Section 7.1 is about integration by parts. And the only formula we need to memorize is this one. Quite short, right? Now, suppose if we need to compute this integral, what should we do in point of view? So on the table, formula table I gave you, integral, can you find any formula of sine and logarithm form? So we know that derivative of sine will be very good. And what is the derivative of cosine? Perfect, negative sine. Here we have sine, but the terms of this is very complicated. Natural log of x, right? And so let us write everything related to these terms, okay? How about derivative of natural log of x here? Beautiful. Can we find the antiderivative of natural log of x? Do we have any formula related to that? We can't find, right? Okay, that is what we know about these things. What do you think? What should we do? Can we make it simpler? We have studied substitution rule and integration by parts, right? Yeah, integration by parts seems to be not applicable in this case right now. Let us try to do substitution. Very good, Alok. Thank you. So let us try to do substitution. So how can we define it? So in substitution, we define a new variable, right? Let us call it u to be what? Beautiful. Very good. ln of x. Therefore, we need the relative change of x and u, right? So if we take derivative both sides, we know that du will be. Yeah, let us do it slowly here. Very good. Or let us write it this way. And we know that this guy is 1 over x. Therefore, the relation between these two guys will be du is 1 over x dx, right? So previously, we need to compute this integral in terms of x. Now we change everything into u. What should we do now? Yes, we need to rewrite the integration here, right? But in order to rewrite it, we need to find the corresponding value in the u coordinate, right? So here, the intervals we compute is when x is equal to 1 to e. At x is equal to 1, then what is the corresponding value for u? Very fast. Let me write it slowly. It will be, we substitute the value of x here, which is natural log of 1, and this is nothing else but 0. Very good. How about at x is equal to e? Very good. Okay, we know everything. Now the integral I is from 1 to e of sine of natural log of x, we can write it in terms of u, right? Now, so sine of natural log of x, we replace ln x by u, right? Very good. The first term is okay. How about dx? So we know the relation between u and x is here, right? From this guy, we know that dx will be x du if we multiply x both sides, right? Okay, let us do it here. Expand it a little bit. Here we go. So we know, let us do a draft here. We know that du is 1 over x dx. Therefore, we multiply x both sides. We have that x du equal to dx here. So it means that wherever dx is, we can replace by x du, right? But can we write it this way? So here, if we write it this way, u will be the variable of the integrations, and x is another, just with respect to u is simply a constant. So we cannot mix up between these two things. Okay? If we change to variables u, we need to change everything into u. So remember, we cannot write it this way. So how can we write everything in terms of u? So we need to find the relation between u and x, right? Okay, but what do we know about this? If we know this guy, the log formulas tell us that. Beautiful. From natural log formula. Thank you, Aluk. So from definition, and we know that e to the u will be x. Okay? If you don't remember this, review log formulas in the formula sheets or go back to 1021 in math websites. There's a link to the videos and materials so that you can review it. Okay, let's go to the math website, you see it. Okay, then we can replace x by e to the u. Very good. Therefore, this integral, we can write it sine of u e to the u du, right? Very good. So, is it enough? Yeah, it is a definite integral. We change the variable, we need also to change the limits, the bounds, right? And we know that at x, the lower limit here is from x is equal to 1, therefore the u will start from this value. At u is equal to 0, to x is equal to e corresponding to u is equal to 1. Okay? Is there any question up to here? We good? Cool. Now, what should we do? We don't have a formula of sine times e to the something, right? And we studied two things, substitution and integration by parts. But here we cannot do substitution anymore. So the only things we could try is to do integration by parts, right? In order to do integration by parts, so we need to draw two columns. That's easy to remember. So we need, let us write one side is derivative. The other side is antiderivative. Okay. So how can we define the u for, the column of derivative? E to the u. Okay, let us try with e to the u. So the antiderivative column will be this guy, right? Okay, sine of u. So on the left column, we take derivative. Okay, what is the derivative of e to the u? Beautiful. E to the u. And antiderivative of, yes, negative cosine. Okay. That's a good catch, right? So now just follow this formula, right? Let us see what happens. If we follow this formula, we need to multiply with this guy. So let me delete here to here. And so the sign of this guy will start with positive and then negative. Okay. Then it becomes a similar problem, right? It is e to the u times negative cosine of u, subtract the integral of negative cosine of e to the u. So what should we do? Because it's just going on and on. It seems that we get nothing from this step.
When it gets back to the original, like what you had, like sine u there, you have, I don't really know how to like explain the words, like.
It's a good point. Thank you, Corner. I understand what you say, but yeah, very good. Corners and Victoria, right? Thank you. So they give us a good point now, but let us do it one more step, one more times, integration by parts, right? If we keep taking the derivative on the left-hand side, what do we have? E to the u, and here antiderivative of negative cosine? Yes, perfect. Thank you. So, and the trick yesterday we studied, we know that, okay, the first will start with positive sign, and we just keep doing it this way. And the sign will change from positive to negative. And the last one will take the integral of these two, and the sign will change from negative to positive. So it means that we do integration by parts twice here. I becomes e to the u times negative cosine u, right? And it has positive sign. And subtract, continue. Can you help me? Okay. And the last terms, we take integral, right? And the sign in front of that is positive. So it will be positive integral of, very good, du, okay? Is it right? Do we need something more? Yeah, the bounds, the limits, right? We are computing the definite integral. And remember, here, it is defined from 0 to 1, okay? So therefore, we need to evaluate it from 0 to 1, from 0 to 1. And the bounds here is also from 0 to 1. Okay, this guy, what is it? This is integral from 0 to 1, negative e to the u sine e to the u. What is it? Let me rewrite it, make it clear. Okay, if we just rewrite it, it will be negative e to the u cosine u, u is equal to 0 to u is equal to 1. The second term is negative and negative give us? Thank you. Plus e to the u sine u, u is equal to 0 to 1. And the last term here, the negative sign, we can take it out of the integral, right? And it will be negative integral from 0 to 1 e to the u sine u du. It's nothing else but I, right? The one we are trying to compute here. The same as here. See? So I is on the left-hand side and it is also on the right-hand side. What should we do to find I? We add I both sides. Then it will disappear on the right-hand side, okay? And on the left-hand side will be, yes, 2i. We know that 2i will be this guy. The whole thing's here. Okay? And let us evaluate this guy. It will be we evaluate the upper limit here, right? It is very good. Minus, right? The lower limit of these whole things here, right? Minus of minus. Very good. Be careful with the negative sign. It's very dangerous. Okay, tricky a little bit. And here, this guy, what is it? Very good. And very good. What is the value of sine 0? Yeah, so this guy disappeared. It is simply 0, right? So in the end, we found 2i. What we need to find is just 1i. So what should we do? Yeah, divided by 2. We have 1/2 of the whole things on the right-hand side, right? And e to the 1 is simply e times cosine 1 and the negative sign here. Therefore, it is negative e cosine 1. This guy, what is the value of cosine 0? Very good. So it will be, yeah, negative of negative give us a plus sign. Plus e to the 0 will be, very good. This guy, that's it, right? Right then. Okay. Do you have any question about this? Are we good? Cool. So this example reviewer's substitution rule and integration by parts. Just do this problems, master these problems, just remind you two things. Very beneficial for you, right? So today, let us continue the section 7.2. In this section, we will study about trigonometry integrals. And yeah, if you don't remember tricks, formulas, look at the formulas I give you. Or use them. Okay, we will go through these examples. Okay. In this section, we will study a lot about, we will apply these guys. And yeah, these properties, identities, identity cosine square plus sine square give us 1 for any angle. Okay. Okay, we'll discuss more when we see the problems. And okay. Let us try to solve example 1 first. Okay. And there's a hint. Let us try. So let us rewrite the question. Sine to the fifth 5 x cosine square x dx. Okay. What do you think about this? And how can we solve it? Which formula you think that would be related to which we can use to solve this problem? Say it again, please. Integration by parts or substitution. Yeah, maybe. But yeah, that is what we study. And remember, derivative of sine will give us cosine. Derivative of sine will give us, a cosine give us sine, right? So somehow, if we make a change of variable, we'll have a clue to solve it. So this guy, we can write it as sine to the fourth of x, sine x, cosine square x dx, right? Okay. Furthermore, remember we have the relation sine square x plus cosine square x here equal to 1, right? So it means that we can write sine square in terms of cosine square plus a number. Or the other way around. Cosine square, we can write it as 1 plus sine square. Okay? It means that these two guys, we can write 1 in another ways, okay? We can interchange it. But there's only, this guy is left, sine x here. It's always here. Okay? Now the hint is to do substitution. Okay? Let us follow the hint for now. And in the future, when you do many problems, you will know how to define these. Okay? So if we let u to be cosine x, what is the relation between du and dx? Thank you. Who was that? Niels, can you raise your hand? Because, yeah, wearing a mask, I don't know where the sounds come from. Thank you, Niels. So we take derivative both sides. Then the right-hand side gives us negative sine x times dx. Okay. Okay, it means that we can write negative sine x dx in terms of u, right? And every terms in cosine, we can write it as a u, okay? So here, we need to write sine to the fourth in terms of u as well, right? So how can we do that? We know. Very good. Thank you, Luke. Okay, we know sine squared is this guy. But what we need to do is to find sine to the fourth, right? We know sine squared, sine to the fourth. If we square both sides, do we have the same equations? Yeah, right. And the target is to write sine to the fourth in terms of u. Now, the right-hand side here, if we write it this way, it will be we replace cosine by u. So the number here, we don't do anything with that, right? We just rewrite the number here. And this is cosine square. We know that u is equal to cosine. Therefore, u squared will be cosine squared, right? So we replace cosine squared by u squared. And this is the all perfect square of these, right? So, and furthermore, I should have written here, yeah, u squared will be cosine square x. Okay, we know everything. Now, substitution tells us that we can write integral to the fifth of x cosine square x here, dx. Yeah, let us write it this way. To the fourth. Now we replace everything here. The first guy here, sine to the fourth, we just found it here, it is. Very good. And cosine square here, u square, and this guy, yeah, we can write it as, be careful. Yeah, du with a negative sign, yes, very good, thank you. Is it clear here? Be careful with the negative sign, okay? Do you have any question up to this point? Okay, good. People on Zoom, is it clear for you? Thank you for your reply. Okay, now everything becomes the integral in terms of u. This is a product of these guys. What should we do? Look at the table in the first page. Binomial theorem. So the first formula in the binomial theorem.
Square the 1 minus 2 squared and then multiply the whole thing by u squared.
Very good. In this case, u is x is 1 and y is u squared, right? The binomial theorem tells us that this perfect square becomes 1 square minus 2 times 1 times u squared plus the second guy is here, square, which is very good, u to the 4th. Everything multiply with u squared, and here negative du, we can write it as du, and the negative sign, let us put it here in front of the integral, okay? So this is the whole parenthesis multiplied with u squared. What should we do? Yes, distribute it. Distribution rule, okay? So u squared here, it will multiply with each of these guys. Right. Which give us, remember, there is a negative sign in front of this. And 1 square is simply 1, right? So 1 square times u square, what is it? Very good. And next. Yes. 2u square times u square give us 2u to the 4th. And the next term? U to the 6th. Very good. Beautiful. And integral properties, this give us at the end, what is it? Very good. Thank you, Angelina. Right. So antiderivative is the reverse way of derivative. So in order to find the antiderivative of u squared, we raise the power of from 2 to 3 and then multiply with a fraction where whole denominator is one of the denominator of this guy is the same power as this. Okay. The constant 2 here, we just rewrite it. This was u to the 4th. So antiderivative will be u to the 5th. And we should divide it by the same numbers. 1 over 5 here, 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 right? Is it enough? Yeah, that is the next step. But at this point, very good, thank you. Miles, right? Thank you, Miles. Yeah. Du is simply a notation. Yeah. So it is. It means that this implies that this integral depends on the variable u. Just notation. Du.
So we don't write du with the next line?
No, in this this step we don't write du anymore. Okay. Thank you. Corner, right? Remember, this is indefinite integral. We need to add a constant. And this constant belongs to the real lines. Okay, this is a constant. So, but what we found is the formula related, depending on you, the original question asks us to find in the terms of x, right? Thank you. So we need to write everything to the forms of x, and it is, so u is cosine x, right? It means that this guy becomes cosine cube minus 2/5 cosine x to the 5th plus 1/7 here, cosine x to the 7th, and add a constant c, where c is in R, okay? So, are we good? Yes, we can stop here, or we can distribute the negative sign, yes. In the test, you can save time by stopping right here. I'm fine with that. But it's more beautiful if we write, expand it, 1/3 of cosine cube. And remember, in front of that is a negative sign. We change sign of the things here. Okay, very good. Good catch. Thank you. So be careful with the signs. It's very dangerous. Should be. Negative here. Thank you. So we good, right? That's it for the first example. The second one here. Suppose we need to compute this guy, integral from 0 to pi of this one. Look at the table I give you, the formulas. Which formula should we use? Yeah, the hint is half angle formula. Say it again, please. Mm-hmm. Thank you. So these formulas, you see it many times, so it's better to memorize it, right? Very good. So now, this integrals becomes a lot easier, right? Okay. Can you help me to continue solving it? Oh, it is from 0 to pi, right? What should we do? Another way to write this is to write 1/2 multiplied with 1 minus cosine 2x, right? It's the same things. But this constant, we can take it out of the integral, make our life easier. Okay? If you see a constant, take it out of the integral. So I prefer doing that way, avoid a lot of mistake. So inside here, give us cosine of 2x dx, right? So the product rule, summation rules tell us that it is the same as integral of 1 dx subtract integral of this function. right? Just the first one, oh, be careful. 1/2 multiply with the whole thing, right? Okay. The first integral here, integral from 0 to pi, is easy. And what is it? Yes. All we do is slowly. It will be antiderivative of 1 is x. Evaluate from x is equal to 0 to x is equal to pi. And finally, it gives us pi. The second one, what is it? What is antiderivative of cosine 2x here? The variable here is x. The angle here is 2x. Angle of cosine. So what should we do? What should we do? Thank you, Nils. We substitute u by 2x. So your job is to go home and try to solve it using substitution rule. This is also the way to review. Okay. So class dismissed here, and I'll see you tomorrow.